Greetings! This is a video to go over the strategy called the equal values method. What is the equal values method? It is a strategy used to solve systems of linear equations algebraically. If you would like more information or more resources on the equal values method, you can refer to the Math Notes box in Lesson 523 in your online textbook. Let's review what a system of linear equations is. It's two or more lines used to find a point of intersection. A system of equations can represent a variety of contexts and can be used to compare two or more things that are related. Let's revisit an example that we looked at in class. We had talked about the Iditarod race, which is the dog sled race held in Alaska once a year. The problem was we needed to find out there was a racer in the Iditarod race and a friend who would like to meet up and cheer her on along the race. We wanted to know that if the person in the race started at the starting line and the friend started at the finish line, where would they meet up at the same time so that the friend could cheer her on? We solve the systems of equations graphically by graphing these two lines and finding the intersection point. And when we found that intersection point, we estimated that they would probably meet up about 94 hours into the race at about 481 miles. This is the solution to the system of linear equations in this example. So we solved it using graphing, but how do we solve a system of linear equations without graphing the equations? First, you want to make sure that your equations are in y equals mx plus b form. I've given an example here of two linear equations, y equals 3x plus 1 and y equals x plus 3. I want to know where these two lines intersect or where they meet. So our first step is to set them both equal to each other. Because both the equations are equal to y, they can be set equal to each other. So we say that 3x plus 1 is equal to x plus 3. Step 2 to solving this problem is now that we have an equation with one variable, we can solve for x. So I'm going to go ahead and use my steps to solve for x. So I'm going to subtract x from both sides of my equation. And that leaves me with 2x plus 1 equals 3. Now I move the 1 to the other side, and I'm left with 2x equaling 2. If I divide both sides by 2, I get x equals 1. I'm not finished here. I only have what my x value is. Remember, when we solve these on a coordinate plane, we need an x value and a y value. The same here. We solve for x, we need a y value. So our next step is to substitute the value we got for x into one of the equations to solve for y. So we had x equals 1. I take that 1 and substitute it into the equation y equals 3x plus 1. When I solve for y, I get y equals 3 times 1 is 3 plus 1. So 3 plus 1 is equal to 4. So now we can state what our solution is as an ordered pair. Our x value was 1 as we solved in step 2, and then in step 3 we solved for y and got 4. So our ordered pair is 1, 4. Let's work out another example. I have two equations here, y equals 2x plus 3 and y equals x plus 5. I want to find out where these two lines intersect on a coordinate plane. I want to find their solution. Because both the equations are in y equals mx plus b, and don't let the second equation fool you. We really have a plus 0 here, but we don't naturally see that. We just write it as 5x. We leave out the plus 0. So both equations are in y equals mx plus b form, so we can set them equal to each other. So I have 2x plus 3 equals 5x. Now I can solve for x. I subtract 2x from both sides. I'm left with 3 on one side and 3 x's on the other. I divide both sides by 3. And I end up with 1 equals x, or x equals 1. I'm not done there. Remember, I need to solve for y as well. So I can pick one of the equations to substitute this 1 in to solve for y. So I'm going to use the second one here. I have y equals 5 times 1. 5 times 1 is 5, so my y value is 5. So the solution to this problem is 1, 5. If we were to graph these two equations, they would intersect at the point 1, 5. Let's look at one last example. This example has two equations. One is y equals 1/2 x minus 1, and the other is y equals 2x minus 7. Because they are both in y equals mx plus b form, we can set them equal to each other. So we're going to follow our steps like we did on the other examples. 1/2 x minus 1 is going to be 2x minus equal to 2x minus 7. Now, we want to solve for x, but we have this fraction coefficient, the 1/2 in front of the x. I'm going to use the fraction buster method to get rid of that fraction to make this easier for me to solve. So in order for me to get rid of this fraction, I'm going to multiply both sides by 2. Whatever I do to one side, I have to do to the other side of my equal sign of my equation. So 2 times 1/2 ends up being 1, or just 1x. 2 times -1 is -2. 2 times 2x is 4x. And 2 times -7 is -14. Now this looks like an equation that I can solve. We got rid of the fraction using the fraction buster method. So I'm going to subtract x from both sides. And I get -2x equals 3x minus 14. I'm going to add 14 to both sides. And I get 12 equals 3x. If I divide both sides by 3, I get x equals 4. Now I need to take this value, substitute it into one of my equations to solve for y. Y equals 2 times 4 minus 7. I took the 4 and substituted using this equation. So y equals 8, because 2 times 4 is 8, minus 7. So y equals 1. I'm not done yet. I need to write my answers in ordered pair. So my answer is 4, 1. That concludes this video tutorial on how to use the strategy equal values method.